Greetings. Good morning. You can see it's dark outside, so it's morning here. What was I going to talk about today? Oh, yeah, I remember. This box. It's a mini computer. It gives me a post error when I start it up, something to do with memory. I'm going to take a look inside of it. Long-term goal, though, is I want to replace my DNS server. It's a Pi hole with a Unbound installed. It works fine. It's Raspberry Pi 3B, but we got Christmas coming up, and I've noticed before that when I have lots of people in the house, the Pi 3B tends to get a little laggy with the DNS requests and stuff. And I looked at this a while back with Top, and the 3B's memory is rather limited. I think that's the cause, but we've got the Christmas holidays coming up. We're gonna have a lot of people in the house in a couple days, so a lot of cell phones, a lot of laptops, a lot. My wife's family's very big, but anyway, I'm gonna try and get this box here working, and if I can, I'm gonna see how it works as a DNS server instead of the Pi. So let's get to it, okay? All right, let's talk about my current system that I'm using. Again, this is with Pi hole on the Pi OS and also with Unbound installed, but it's a Raspberry Pi 3B quad core 1.2 gigahertz Broadcom CPU. This is a ARM class CPU, which is a subclass of RISC processor. 1 gigabyte of RAM. I think that's probably the issue. 100 base Ethernet. I'm using a micro SD card for storage. This is a very low power unit. It's very quiet also. At 2.5 amps is the USB adapter power requirement. There are some issues with this device, though, performance issues specifically. Again, when I'm running the web GUI and I have multiple clients, and I verify this with Top, the 1 gig of memory gets consumed and the system starts lagging. It's also, when I do a restart, it's slower to boot up than I'd like. That's because it's booting off a micro SD card instead of an actual internal drive. And network could be faster. I don't think that's really an issue, but it could be a gigabit instead of 100 base. But anyway, that is the current system I'm using. Now, the mini computer I picked up is a second generation Intel NUC. It's got a i5 processor, 1.8 gigahertz with a turbo up to 2.8 gigahertz. This is an older processor. It's 2 threaded cores, or a total of 4 logical cores. It can take up to 16 gigabytes of RAM. We'll see what's in there when we get to it. The installed Ethernet port is a 1 gig. One interesting thing, according to the specs, it's using an mSATA storage drive as opposed to a SSD or an NVMe. mSATA is sort of like an SSD on a small little M2 style card as opposed to a full-size SSD. It does have a USB 3 port, which is something the Pi didn't have. I made an estimate on the power based on the power supply that comes with it, so and some of the components that the spec sheet says it has inside. So I'm estimating 8 to 10 watts idle and probably around 25 watts max load. It is about twice the size as the Pi 3B. Also has a fan, so it does make a little bit of noise, although this is a server, so it's out of the way, and that's not really a critical issue. As I said, the big problem right now is it gives me a post memory error and doesn't boot up. So we're going to take a look at it and see what's going on there. All right. So here we have the unit. Let's go ahead and open it up. You can see the rear ports here. There's the USB 3 on the front. Looks like it's held in by 4 screws through the feet. No other indications of a way to open it, so we'll take these screws out. Well, looks like they're captive screws, so we're not going to be taking them out, but we'll loosen them. All right, the bottom comes off. And looking inside, we can see the memory, and we can see the mSATA drive, and there's something under the mSATA drive. Let's see what that is. Let's see. Okay, get the mSATA drive out first. And yes, this is an mSATA drive. 256 gigabyte mSATA. You can see the slot there. And underneath the mSATA is another M2 card, slot card. This one is, it looks like it's a Wi-Fi card, and it may also have Bluetooth on it. We're not going to really need that with this build, so I'm going to go ahead and take this out. Don't know if it works or not, but if it does, we can use it maybe in another project, but we don't need it here. You'll notice they don't have center slots on these. This is the old PCI Express style of M2 slot, and the screw holes are on either side. So yeah, I'll have to look it up. It looks like it's a Wi-Fi. Oh, here's a problem. One on the side of the memory clamp wasn't engaged. This is Kingston KVR 16LS11/8. Look that up. It's an 8 gigabyte stick. There's 2 of them, so that does mean this thing has the full 16 gigabytes installed. That's a little overkill for my application, but okay. Yeah, the one side of the memory holder was loose on this one, so that might not have been seated properly. Might be why we got the post error. This one seemed to be seated okay. Okay, gonna do a little cleanup. We'll tape up the Wi-Fi leads, and we'll put this thing back together without the Wi-Fi card and see how it runs. Before getting too far along, I want to take a minute to discuss what this Pi Hole DNS server is actually doing. So assuming DHCP default configuration for your router, or my router anyways, which is EG8145 from Converge, it will go out and hit the DNS of Converge. You can actually go in the router and change where the DNS points under the DHCP page. You can point it to like Google or Cloudflare. I am going to point it to my DNS router internally. So we look at our diagram over here, red arrows indicate a request from my computer to the router. We can follow the blue arrows. It goes back from the router into my DNS server and to my Pi hole, which is running on port 53, which is the default DNS port. Since this is the local request from my computer, there's nothing for Pi hole to do with it. Pi hole, for those who don't know, is basically an ad blocker. So it forwards the request on port 5335 to a local address 127.0.0.1, which basically sends it to the Unbound DNS server. Unbound looks at the address, it checks against its list of authoritative domain servers, and it also checks against its internal DNS cache. If it's in the cache, it goes ahead and requests the IP address directly. If it's not in the cache, it'll send a request to an authoritative DNS server for the address, the IP address. You might be wondering what the difference between authoritative and non-authoritative DNS servers are. Well, servers like Google are non-authoritative. They take your request and forward it to an authoritative DNS server, but they also track your DNS requests. Doing it this way, you're tracking your own DNS requests and you're going directly to the authoritative server and not through a third party like Google. So that's basically what's happening with my DNS server on my network. So now that we got the NUC up and running, we're going to go ahead and install Debian 12 on it, and we're going to build our Pi Hole / Unbound DNS server on Debian 12. There are other videos and articles. In fact, I published a few on installing Debian, so I'm not going to go into it in detail. I will talk about a couple problems I had with this particular install. So when I tried to install a UEFI install on the NUC, it didn't work. I think the BIOS is old and the UEFI available is an older version and it doesn't really play nice. I've seen this issue before on older computers. When I'm talking older, it's like 5 to 10 years old. UEFI was in its infancy back then. In some cases, this one particularly, it didn't work like I was hoping. It wouldn't boot. However, since this is a DNS server, it's basically going to have two partitions, and the internal drive is smaller than 2 terabytes, so we can actually get away with legacy boot, which does work fine. In fact, that's what we were using on the Pi 3B for this. So yeah, we're going to have a master boot record on our drive, and we're going to do a legacy boot, and like I say, it's not going to really make a difference in this case. Installing Debian, we're going to use USB 3 because it's available on the NUC and it wasn't on the Raspberry Pi. USB 3 is much faster, and well, for the Raspberry Pi, you're doing the install a little differently from your computer, writing an SD card, so it's generally a simpler, cleaner process doing it on the NUC. The server is going to be running headless, so when we load Debian, we got to make sure that we install an SSH server package also so that we can remotely connect. And the last bit here is we're going to need a static IP address set up also. You can do that during install or after install. It's really up to you when you want to do it, but I would suggest doing it during install is probably better. And other than that, it should be a standard install for Debian. Okay, it's been a few hours, more than a few hours actually, and I've got this thing working. So let's go take a look. I actually sort of did things backwards. I installed Unbound first and rebooted my DNS server to get it working. There was some issues until I rebooted and they went away. So I can use systemctl and grep Unbound and I can see the service is active and running, or I can use the status Unbound to get more detailed information. So we're running without error here. And like I say, I had to restart to get to this point. Then after this, I went ahead and installed the Pi Hole script using curl. If you go to the website, yeah, this page, it gives you the curl command. It will download the script and run the script that will do the installing. And it's pretty much self-explanatory. I went with the defaults. The big thing is on the last page, you'll get a password. You need to remember that password. Then this section is on installing Unbound. You got some short description on what you're actually doing. And what you're going to create is an Unbound configuration file for the Pi. So you got the address there, where it goes, and the actual script itself here. How you want to get it onto your computer is up to you. I pasted it in with SSH using PuTTY. That was the easiest for me. So if we come back here and we were in the etc unbound directory, or etc unbound as some people like to say, and you can see we've got the unbound.config and the unbound condition config D. So look in there. The last line is the important one, which basically tells it to run everything in the unbound.config.d folder that ends in a config. That's all that's in this file. And if we list the files in this folder, you can see we've got the Pi Hole config, which is what we were told to make, and we've got a couple other files that were installed by default. And as you can see, it's basically the same file that was on the website. Again, I had to restart the computer to get this to run without issue. I had a few errors on initial install, but once I rebooted, it was fine. Next thing you need to do is you need to get, well, this is your login screen you should get, and the password that you got off that last screen when installing goes here. You hit the remember me if you want. Go ahead and log in. You can see we've been running for several hours here. We've got some blocked data, about 30%. Anyway, you're going to want to go to settings, and from settings you're going to want to select DNS from the top tabs. Now whatever DNS server you selected during install will be checked here. You're going to want to uncheck it. I did Google, so I just unchecked Google. You're going to want to check custom one, and you're going to want to enter the local IP address 127.0.0.1 and port 5335. You can also, if you want, add some local domain or local servers. I've got both my my DNS server and my media server listed here. So that takes us 3/4 of the way there. There's one final step because you want everything on your network to use this. So you got to log into your router. This is my router's login page. I go to advanced, I go to LAN, and I go to DHCP. And down towards the bottom, you'll see primary and secondary domain or DNS servers. Enter your address for your DNS server. I entered mine here and save. That way anybody logging onto your network automatically will go through the Pi and Unbound. Your router, of course, may have a different panel layout. You're going to have to look around to find out where things are. And that is pretty much it. After that, it would just let it run for a while, and it was running good. Adding additional block lists is beyond the scope here, but there are other ones you can add. I may do something on that a little later. Well, that was it. The Pi's been replaced by the NUC. The NUC seems to be running good. I didn't show running top on it, but it's using very little in the way of resources. So we'll find out. We got our Christmas party the 23rd, so we'll find out when the family's over here. If it gets any bogged down, I'll have to open the web interface so I have everything going at once, and we'll see how it's running. But I think even though it draws a little more power, this is going to run a lot better. There's some more stuff I want to play around with, but for right now, I'm going to call it good, and If anything else comes up or anything changes, I'll do some more posting. So see you later. Bye.